At the lowest level, all input and output is done in streams. A stream is simply one byte after another in sequential order. When you're reading an input stream, it's up to your program to interpret the meanings of the incoming bytes. When you're writing a stream, it's up to your program to organize the outgoing bytes in a form they can be read and understood by some other program as an input stream. This is the documentation page of the input stream class. This is an abstract class, so it's only used as a superclass for other stream classes to get their data from a specific location. Here are all of the subclasses. Each one specifies that the input come from a different source. And where there is input, there is output. There are companion output stream classes that write to different types of targets. You select the class designed to work with the type of thing you want to read or write. Once you have that done, they all work fundamentally the same, so I can show you how a file input stream and a file output stream work, and you'll have a good idea of how they all work. Now, this program works the same way as the previous copy file program, except this one uses stream objects. Just like before, a couple of file objects are constructed to represent the files themselves. The file objects are used to construct file input stream object and a file output stream object. The read and write methods are used just like the ones that were used earlier in the file reader and file writer objects. And calling the close methods on the two of them closes the stream for input and output. So far, everything has been read and written has been character data. There's a special pair of stream classes that allow you to read and write any type of data you choose. A streamFile2 object first writes data to a file and then reads it back. To do this, it uses a data input stream and a data output stream. As usual, a file object is created so it can be used to address the output file. You could actually skip this step. If you look at the constructor for the file output stream class, you'll see that there is one that accepts the string name of the file. You could use that, but this way seems to me to be a little more robust somehow. This should make future changes and whatnot easier to do. Anyway, a new file output stream is created and will be used to write to the file. If the file already exists, that's okay, because opening it this way will cause it to be overwritten by a new file. From the file output stream object, a new data output stream object is created. It is this class that has the methods for the different data types. It understands the layout of the different data types and will write the data as streams of bytes. Here you see that there is a write method for each of the data types. The data for each type is written unmodified to the file. For instance, the double value in the file is exactly the same format as a double value in memory. Now, the UTF string may be modified during output. In memory, each character is held as a 16-bit value. However, most of the characters in a string are ASCII and can be stored in 8 bits. So, those are written as 8-bit values to the file. The others are written as 16 bits. There's a special encoding involved so the reader of the file can tell which is which. Finally, the file is closed, which flushes any buffering and closes the file. The read data method reverses the action. It reads the data that was written to the file. A text window is constructed first to display the output, and a new file object is created to represent the file itself. A new file input stream object is created, providing access to the file, and a new data input stream object is created to read the input stream of bytes and interpret the data types. Each data type has its own method to read one or more bytes from the file and interpret the data. Here, a single byte is read from the file and interpreted as a Boolean value. Each method is used to read a specific data type. Each has its own specific file format. The types are read from the file in the same order they are written. Each one is displayed as it's returned from its read method. The same values that were written to the file are returned and displayed. If you compare these values displayed here against the ones that were originally written to the file, you'll see that they are the same. I have included a simple utility on disk that will give you a raw hexadecimal dump of the file itself so you can see the file representation of each data type. You can see here that the value of the first byte is 1, which is the file format of a Boolean true. Next is the character X, which takes up 2 bytes because a character is a 16-bit value. The display format lists some of the displayable bytes over here on the right. Some are displayable values by coincidence and some because of the actual data. These 4 bytes here are the int, and the rest of the line is the floating point number. The last 4 bytes here are the 4 characters of the output string.